Hello everyone. What we'd like to do in this video is we'd like to start getting practice with evaluating inverse trig functions. I know in the last video it might have been a lot thinking about the inverse sine, inverse cosine, inverse tangent, or arc sine, arc cosine, arc tangent. It's good to know what their graphs are. The key thing to realize and the key thing to really remember is what angles do each of those trig functions spit out. So let's get practice with using them. Before doing that, what I'd like to do here is think about what the tangent of these, of pi over 6, pi over 4, and pi over 3 should be. Let's add them to this unit circle. So let's go ahead and do that. So let's think about what's tangent of pi over 6? What's tangent of pi over 6? Remember, tangent is sine over cosine, or you could think of tangent as the slope of this line on the unit circle. Well, the rise is 1/2. And the run is root 3 over 2. So I have this fraction divided by this fraction. So this will be 1/2 times 2 over root 3. These two cancel. We get a 1 over root 3. It's very common, specifically in trig, to not have radicals in the denominator. There's nothing wrong with having a square root in the denominator. It's just a common form that a lot of books like to use. So we're going to rationalize the denominator by cleverly multiplying by 1, root 3 over root 3. So that's just going to give us root 3 over 3. So I'm going to kind of write this right here. The tangent, I'll write tangent in red up here. Tangent of pi over 6 is root 3 over 3. Okay. Now, if I want to know what tangent of pi over 4 is, well, that's the easy one. Well, tangent of pi over 4, well, that's going to be sine over cosine. So that's root 2 over 2 divided by root 2 over 2. That's just 1. You can also hopefully see that the slope of this line right here is 1. So tangent of pi over 4 is 1. So I'll put a 1 here. Okay. Well, what about tangent of pi over 3? Tangent of pi over 3, well, let's see here. That's going to be root 3, since it's sine over cosine. It's root 3 over 2 all over 1/2. So this is root 3 over 2 times 2 over 1. These 2's will cancel, and we'll just be left with a root 3. So here's a root 3. Okay, how do I remember these? Well, I remember for the first quadrant with tangent is it's either going to be a root 3 over 3, a 1, or a root 3. So there's a lot of 3's there. It's easy for me to remember that tangent of pi over 4 is 1, but there's root 3 over 3 and root 3. Well, I hope you believe that root 3 is bigger than root 3 over 3. Which one has the bigger slope? This has a bigger slope, so this must be root 3, and this must be root 3 over 3. So that's a little bit, that's the trick I use to remember tangent on the first quadrant of the unit circle. Okay, so let's get some practice with evaluating the inverse trig functions. Okay, so we'll do a bunch of examples. Okay, let's do sine. Let's start with sine. What is sine? Sine inverse, or arc sine of root 2 over 2. Now, all we just have to remember is I'm asking at what angle do we get a sine of root 2 over 2? But we have to remember that the sine inverse function only spits me out angles between negative pi over 2 and pi over 2. So maybe I should write that. This is negative pi over 2. It just means we're rotating clockwise. And here is pi over 2, except with no negative. Okay. Well, just looking at the unit circle, when do I get a height of root 2 over 2? Well, that's at pi over 4. So the answer is pi over 4. This is asking what angle between negative pi over 2 and pi over 2 gives you a height on the unit circle of root 2 over 2. The answer is pi over 4. Okay, let's do another one. What about sine inverse of negative 1/2? Now this one's a little bit different. What it's asking us is we want to know what angle on the unit circle gives us out a height of negative 1/2. Well, let's think about it. Well, here we get out a height of 1/2. So down here, this would be a height of negative 1/2. Now remember, it's got to spit me out an angle between negative pi over 2 and pi over 2. So we want to think about this angle right here. We want to think about this angle right here. So if this is pi over 6, this here will be negative pi over 6. If I travel negative pi over 6 radians, we'll still have an x-coordinate of root 3 over 2, and we'll have a y-coordinate of negative 1/2. So the answer is negative pi over 6. Okay, how about let's do sine of, how about negative 2, for example? Sine of negative 2. Oh, sorry, sine inverse of negative 2. Sine inverse of negative 2. So this is asking us that I want to know what angle gives me a height on the unit circle of negative 2. This doesn't make any sense because the sine function only spits out ratios between 1 and negative 1. So sine inverse only eats ratios between negative 1 and 1. So I can't plug in negative 2 into the sine inverse. This is undefined. This is undefined. There is no height on the unit circle of negative 2. Let's do some more examples. Let's say that we want to know what the cosine inverse of 1/2 is. Okay. So remember how inverse functions work? They eat ratios and spit out angles. So I want to know what angle gives me an x-coordinate of 1/2. If we look at our unit circle here, okay, looks like I'll get x-coordinate of 1/2 at root pi over 3. So at what angle do I get a width of 1/2? An angle of pi over 3. This is the answer. Okay, how about we try cosine inverse of a negative root 3 over 2. Okay. So I want an x-coordinate of negative root 3 over 2, Well, here we have an x-coordinate of positive root 3 over 2. If I want the negative coordinate, I want it right here. I don't have a super perfect circle here. Right here. At this spot right here. So the coordinates here are negative root 3 over 2 and 1/2. Now, there are actually two locations. There are two angles. There's this angle that spits out a x-coordinate of negative root 3 over 2, and there's also this angle. But we have to remember that what angles does cosine inverse spit out? Cosine inverse only spits out angles between 0 and pi. So what angle do I record? I record this angle right here. Okay, so what is that angle? It looks like if we go all the way pi and subtract a pi over 6, this is going to be 5 pi over 6. And this is the answer. Okay, let's do some more. Okay, let's say we want to know what tan inverse of 1. So go ahead and take a second and try to think about what tan inverse of 1 should be. So what we're asking here is we want to know what angle on the unit circle, in this case if it's tangent, gives us, I guess, the slope on the line of 1. Well, there are actually two locations. Okay, the location right here, this will give us a tangent of 1, but also this location over here, what would this be? This would be pi, this would be pi, let's do 4 pi over 4 plus another pi over 4. So this is 5 pi over 4. So at pi over 4 and 5 pi over 4, those are two locations, or those are two angles that give me an output, that give tangent an output of 1. So, but I only want the angle, remember how tan inverse works, I only want an angle between negative pi over 2 and pi over 2. That's how tan inverse works. It only spits out angles between negative pi over 2 and pi over 2. So which one do we report? We report pi over 4. So this is the answer. tan inverse of negative root 3 over 3. Take a second to think about this. Okay, so I need to figure out an angle between negative pi over 2 and pi over 2 that gives me a tangent of negative root 3 over 3. Well, if we are looking over here on the unit circle, well, this height here, or this slope here would be root 3 over 3, which means that actually this slope here, if I go down, this slope here would be negative root 3 over 3. So this location should give me a tangent of negative root 3 over 3. This location also, but what angle do I report? I don't report going all the way around to this one, or I don't report this one. I report the negative angle. Tan inverse spits out angles between negative pi over 2 and pi over 2. In this case, we would report negative pi over 6. Negative pi over 6. And this is the answer. Okay, let's try a lot more. Now, how do I do these? I mean, I just usually always just think about the unit circle. Let's try to do it without even the unit circle here. Let's try some more. Let's put a couple more up on the board. Okay. What is sine inverse of negative root 3 over 2? What is cosine inverse of, how about root 2 over 2? What is tan inverse of root 3? And let's also do, what would be sine inverse of positive root 3 over 2? How about also cosine inverse of negative root 2 over 2? And how about tan inverse of negative root 3? Take a moment and try to find the outputs of these 6 functions. Okay, let's do it. I'm going to erase a few of these. Let's do the sine ones first. Okay, let's go ahead and draw a unit circle. So this is how I'm going to think about it. I need a height of root 3 over 2. So I'm going to think about what's going on in the first quadrant. So I'm going to use a hand trick. I need a root 3 over 2. I need the y coordinate to be root 3 over 2. So I need to put down my pi over 6 finger. So let's draw the picture. Okay? So this would be our pi over 6 finger. This is where I have a 1/2 and a root 3 over 2. Okay, but I need it to be negative. Okay, so I need a negative height. So the negative height would be over here. So this will be a 1/2. This will be a 1/2. I guess maybe I should drop it down. It's not a perfect circle. Let's just draw it a little bit better. So here is 1/2 and root 3 over 2, but I want a negative 1/2. That would be right here. So this would be the coordinates 1/2 and negative root 3 over 2. So I want to report the angle that gives me the output of sine output of negative root 3 over 2. Okay, I don't want to report this angle because remember, sine inverse only spits me out angles between negative pi over 2 and pi over 2. So if this angle right here is pi over 3, this angle right here is going to be negative pi over 3. So the answer here is negative pi over 3. This is the answer. Okay. What would it be for positive root 3 over 2? Well, I get a sine of positive root 3 over 2 when I'm at pi over 3. Or pi over 3. Okay? So that's the answer for these ones. Okay. Let's do the cosines. So we had the cosine inverse of root 2 over 2. And we also want to do the cosine inverse of negative root 2 over 2. Okay, so if we're going to use our hand trick here, okay, where do I get a x-coordinate of root 2 over 2? Well, we put down our pi over 4 finger. The x-coordinate is root 2 over 2, so there's really not too much more work to do here. I mean, you could draw a unit circle if you'd like, but I know it's going to be at pi over 4. Okay. What about at negative root 2 over 2? We need to be a little bit careful here. I might want to draw the unit circle. We're drawing the unit circle. Okay. I know right here, this is where we have a coordinates of root 2 over 2 and root 2 over 2, but I need a negative x coordinate, so that's going to be over here. So this is negative root 2 over 2 and root 2 over 2, okay? So right here and also right here give you out an x coordinate of negative root 2 over 2, but remember that cosine inverse only spits out angles between 0 and pi. So we want to report this angle. So what is that? 1, 2, this is 3 increments of pi over 4. So this is 3 pi over 4, and this is the answer. Okay, let's do the tangents. Okay, we had the tan inverse of root 3, and we also wanted to think about what the tan inverse of a negative root 3. Okay, let's draw the unit circle. Okay, we're thinking in the first quadrant, there's these 3 spots here. Okay, which one gives me the slope of root 3? Well, there's root 3 and then root 3 over 3. This has to be root 3 over 3 because it's smaller than root 3. So we're right here. This is where tangent, see, this is where tangent is equal to root 3. And what angle is this? What angle is this? Well, this is pi over 3. This is pi over 3. Okay, but so the answer here is pi over 3. Remember that tan inverse only spits out angles between negative pi over 2 and pi over 2. So this is going to be helpful for this version here. I want this slope, but I just want the negative slope. So that's going to be this spot right here. So this is where tangent of blah, this is going to be equal to a negative root 3. So you don't want to report this larger angle. The way tan inverse was built, or the way mathematicians decided to build it, is tan inverse is going to spit out the angle between negative pi over 2 and pi over 2. I need to report this angle, which is negative pi over 3. So the answer here is negative pi over 3. And these are the answers. Okay. Now, when we're evaluating trig functions, we actually need to be a little bit careful. Specifically, not just evaluating trig functions, but specifically when working with compositions. Okay. Compositions. Note, we need to be careful. Okay. So here's an example. Let's say that we have sine of 5 pi over 6. We're evaluating sine at 5 pi over 6, and then we apply the inverse to it. Okay, so I'm composing a function with its inverse. So recall, if you normally take a function f of x, and you compose it with its inverse, it usually just spits out x. So you may be tempted to say that this should be 5 pi over 6. Unfortunately, you would be incorrect. You could be incorrect. It's not going to spit out 5 pi over 6. Let's see why. What's going on here? Let's evaluate this from the inside out. Okay, let's think about what sine of 5 pi over 6 is going to be. So let's look at it on the unit circle. So I need to move 5 increments of pi over 6. So 1, 2, 3, 4, 5. We're right here on the unit circle. So here is an angle of 5 pi over 6. And I want to know what the y-coordinate is here. Okay, well, we can think about what it is in the first quadrant. Okay, so over here, it's root 3 over 2 and 1/2. Okay, so over here, the x-coordinate is negative, so this is negative 1/2. Oh, I'm sorry, the x-coordinate is negative. Negative root 3 over 2 and 1/2. Okay, so here we would have sine inverse, okay? Well, sine of 5 pi over 6 is 1/2. is 1/2. Okay, so now what we're going to ask ourselves is, well, what is sine inverse of 1/2? Well, in this case, remember how sine inverse works here. Sine inverse only spits you out an angle between negative pi over 2 and pi over 2. What's sine inverse of 1/2? Well, what angle between negative pi over 2 and pi over 2 gives you a height of 1/2? That's this angle. This is pi over 6. So this answer here is pi over 6. So notice here that actually sine inverse of sine of 5 pi over 6 is not equal to 5 pi over 6. It's actually pi over 6. Now the reason it does this is because, well, the way we built sine inverse is we built it to only spit out angles between negative pi over 2 and pi over 2. So this actually does not spit out 5 pi over 6. It spits out pi over 6. So we need to be careful. Don't just automatically cancel these. We actually need to look at the unit circle, and we actually need to do the composition. You need to do the inner evaluation, and then you need to plug that into the sine inverse. Let's do some other examples. Let's say we wanted to do cosine inverse of the cosine of pi over 4. Take a moment to think about what this here should be. Okay, let's do it. So what is cosine of pi over 4? Cosine of pi over 4, okay, we put down our pi over 4 finger. The x-coordinate is root 2 over 2. So here we'll have cosine inverse of root 2 over 2. Okay, so we're on the unit circle here. This is where we are. This is pi over 4. This is root 2 over 2 and root 2 over 2. So now we're asking, at what angle do we, between 0 and pi, do we get an output of pi over 2? Well, pi over 4. So in this case, it did work out. Cosine inverse of cosine of pi over 4 is pi over 4. Is pi over 4. Okay, so sometimes it'll spit out exactly what's in here. Sometimes you need to be a little bit careful. It really depends on what angle you have inside here. If this angle you have inside here is the type of angle that cosine inverse spits out, since pi over 4 is between 0 and pi, it's going to spit out pi over 4. In the last example, when we had sine inverse of sine of 5 pi over 6, well, the reason it didn't spit out 5 pi over 6 is because sine inverse only spits out angles between negative pi over 2 and pi over 2. So it kind of makes some adjustments. It doesn't spit out 5 pi over 6. It spits out the angle that gives me that sine output that's between negative pi over 2 and pi over 2. And that's why this one here spit out, what did it spit out? I think it spit out pi over 6. Okay, so it kind of depends on what this angle is inside here. Here, it's just pi over 4, because pi over 4 is between 0 and pi. 5 pi over 6 is not between negative pi over 2 and pi over 2, so we need to be careful with this evaluation. Okay. Let's do some more for practice. Okay. So let's try the following. How about sine inverse of sine of 7 pi over 6? Okay. How about cosine inverse of the cosine of 5 pi over 3? Let's try one more. How about we do the tangent of sine inverse of root 2 over 2? So take a moment and try to evaluate these three functions. Okay, let's go ahead and do this. What are we going to do? I'm going to look at the unit circle for all of these. Okay, so for this first one, okay, 7 pi over 6. 7 pi over 6. Where are we on the unit circle? Okay, you could think that I went I think that I went all the way a full pi and an extra pi over 6 if you'd like. Or we could just count. Here we have 1, 2, 3, 4, 5, 6, 7. So this is where we are on the unit circle. This is 7 pi over 6. Let's think about what the x and y coordinates are here. Okay. Well, they both got to be negative, and if I'm thinking over here, the x coordinate is root 3 over 2, and the y coordinate is 1/2, except they'll both be negative over here. So this will be negative root 3 over 2, and this will be negative 1/2. You can kind of think here, if you kind of dot your line over, I'm down negative 1/2. Okay? So what is sine of 7 pi over 6 going to spit out? Well, that's going to spit out negative 1/2. And now we want to know, what is sine inverse of negative 1/2? What is sine inverse of negative 1/2? Well, this is going to spit out the angle that's between negative pi over 2 and pi over 2. So this is where we have a height of negative 1/2, but we have that same height over here. So I want to think about what this angle is, but I got to think about the negative angle. So it'll be this angle right here. And this angle is negative pi over 6. So the answer here is negative pi over 6. Okay. Let's do this cosine. Let's do cosine. Okay. So I have a 5 pi over 3. Okay, where are we on the unit circle? If you would like, you could think about this as, how about 10 pi over 6? I'm just multiplying top and bottom by 2. So if we're on the unit circle. Okay, we got to go move 10 increments of pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is where we're at. Okay, so this is an angle of 10. This is an angle of 10 pi over 6, or 5 pi over 3. Okay, let's think about what the x and y coordinates are. Well, this will be the same as we put on our pi over 3 finger in the first quadrant. So the coordinates here are 1/2 and root 3 over 2. So the coordinates here, the x coordinate is positive, the y coordinate is negative, negative root 3 over 2. Okay, so what is cosine of 5 pi over 3? That's the x coordinate, that's 1/2. So this is 1/2. What is the cosine inverse of 1/2? At what angle between 0 and 2 pi do I get an x coordinate of 1/2? Well, that's this angle right here, and that's going to be pi over 3. So the answer here is pi over 3. This is the answer. Okay, let's do this last one. What was it? We had a mix of a tangent and a sine. We had what? Tangent of sine inverse of root 2 over 2. Okay. So let's think about what sine inverse of root 2 over 2 is. Well, this is something that's kind of nice to work with. What angle gives me a height of root 2 over 2, or a y coordinate of root 2 over 2? If we use our hand trick, well, that's going to be at pi over 4. So here we'll have tangent of pi over 4, tangent of pi over 4. What's tangent of pi over 4? I hope you believe it's 1. And that is the answer. Okay. So that's how we work with the inverse trig functions. Just got to be a little bit careful with them. You just have to really remember that sine inverse spits out angles between negative pi over 2 and pi over 2. Cosine inverse spits out angles between 0 and pi. Tan inverse spits out angles between negative pi over 2 and pi over 2. Be a little bit careful. Draw a unit circle. You'll be good to go. We'll see you in the next video. Take care.